Hello everyone, welcome to the discussion. Today we are going to discuss AASL paper 2, paper 1, question number 9. So this is a trigonometry based question and it carries totally 15 marks. So let's break down the concept and solve this. And here we go. First, a function is given and its domain is also given. So function is cos square x minus 3 sin square x and the domain is between 0 less than or equal x less than or equal pi. From 0 to pi. First part, find roots of f of x is equal to 0. Roots means just solve that. Solve for x. F of x and let me equate to 0. Let's solve this further. Cos square x minus 3 sin square x equals 0. Right, two different functions is there. Let's try to convert into one, like either cos or sine. And we can apply the identities and those are simply available in our formula booklet. Right? So, right. I'm going to change this into complete cos form. Right? Let's start. And here is the formula. Let me share the formula booklet here. The basic identity. Cos square plus sine square theta is equal to 1. I want to replace the sine square with cos. So this can be applied. So let's take this and let's get into the formula page, solution page. So this is what I'm going to use. This is the formula. And so I need to replace sine square x. So sine square x can be written as 1 minus cos square x. Let's apply that. Cos square x as it is minus 3 whole bracket 1 minus cos square x equals 0. Now we turn this into single function. Let's simplify it. Like remove the bracket. Cos square is minus 3 plus 3 cos square x equals 0. And 3 cos square x and this cos square x is 4 cos square x minus 3 equals 0. For sure, two factors it can be expressed. It's a quadratic in cos x, right? This is a quadratic equation in cos x. Usually we will see with x, but here cos x. And let's simplify it. 4 cos square x can be written as 2 cos x the whole square minus 3 can be written as root 3 square. So what I'm trying to do, a square minus b square, right? Yeah, it can be expressed. So it's very simple and you can use this identity. We already know a square minus b square can be break down into a minus b into a plus b, right? So let's use this. Here a is 2 cos x. So 2 cos x minus root 3 times 2 cos x plus root 3 equals 0. Right. And each of the factors you can equate to 0. 2 cos x is root 3 over 2 or 2 cos x is minus root 3 over 2. Solving further, cos x, wait. Actually, this 2 is not there. So cos x is equal to root 3 over 2 or cos x is equal to negative root 3 over 2. Now, to solve this, I have to look, this value should be memorized, right? So at which angle cos will be root 3 by 2? The principal angle at first quadrant. So cos will be root 3 by 2 at this particular angle, 30 or 60. Let's check. And also here they have mentioned in radians. So always they expect to get the best score, give the answer also in radian, right? And why? Because this is 0 to pi they have given, right? So cos 30 degree is root 3 by 2. 30 degree in radian form is pi by 6. So principal angle or reference angle we can see. Now I want to solve for cos root 3 by 2 from 0 to pi. Here cos is positive and yeah, root 3 by 2 will exist in this quadrant, root 3 by 2, but with a negative root 3 by 2 in this quadrant. So 0 to pi when I solve, my only solution is here. And here the direct reference angle, the acute angle will work. So x is equal to cos inverse root 3 over 2, which is pi by 6. Make sure we are giving it in radian form. Then cos x is minus root 3 by 2. It is not in first quadrant, in second quadrant. Second quadrant is an obtuse and it can be expressed as pi minus that reference angle. So what is the reference angles? Everywhere I am solving for cos root 3 by 2. But in which quadrant? It depends upon. So my answer is x is equal to pi minus root 3 over 2. Sorry, pi minus cos inverse root 3 over 2. So what is cos inverse root 3 over 2? We know that direct value. So pi minus pi by 6. So x is equal to 5 pi by 6. So I equate f of x to 0 and I got two values. This is nothing but the given function. If you graph it, the graph meets x-axis at these points. So like these are x-intercepts of f. We can interpret this result here. And it can be applied in future problems in this section. So x-intercepts are pi by 6 and 5 pi by 6 in the interval 0 to pi. Right? That's simple. Now let's move on to the next part. Find f dash of x. Okay. Derivative, differentiation. Let's write f of x. F of x we simplified into one function, right? That will be better, right? Not in the factored form, the simpler form, like turned into one single function, that one. So this is my f of x, right? I solved, and I just made it like this. Simpler and only one function involved. It is 4 cos square x minus 3. Now let's start differentiating. And we are going to differentiate using the, okay, if it's cos x, direct differentiation is there. But what if it's cos square x? Like it's a composition of function. So when there is a composition of two functions like square and cos, both get composed here. And we will use chain rule, right? So let's apply chain rule and I will show you how the chain rule will work. Let me share my screen. It is available in the formula worksheet, formula sheet. Let's go. Derivative part we need to check. And composition of function is there. The chain rule. Y is equal to g of u and u is again another different function. So this is your this rule and simplify in simplified format. So first differentiate y with respect to u, then differentiate u with respect to x. Right? So let's take this formula and use it over. Let's switch to the solution page. Okay, this is our reference. Right. And also there is another easy way. F of x is equal to 4. Let it be as it is. You apply the 2 first, like a square. So when you differentiate that square, it's 2 cos x, right? And then you differentiate the u. Like you can treat it as u square. U, or you can treat it as, yeah. First you differentiate this u square. This u square, let me call it as y. So when you differentiate, it is 2u. So 2 cos x times. And this we can do in a single row. No need to solve it, but I will solve in a much simpler way also. So this is a trick we can use. So 4, first apply the power rule. How power rule works? You will multiply and you will reduce the power. That's it. Then extra you multiply and do the base differentiation. The simple base is cos x, its differentiation is minus sin x, and this minus 3 will become 0, right? So I got minus 4, 2 sin x cos x. So whenever you see this, you can spot, okay, 2 sin x cos x seems to be a rule, right? So this is a trigonometric identity we have, and we can convert this into minus 4, like 2 sin theta cos theta can be written as sin 2 theta. Double angle formula. Okay. So it can be written as sin 2x. 4 sin 2x, much simpler form. This is one way. Let's go with this formula way. So 4 cos square x is what I'm differentiating, and 4 is simple. It's a constant. Let me focus on cos square x, how it can be. So let me treat it as y is equal to cos square x. Okay, so y is equal to cos x is a problem. Let me convert it to u square. I know it's easy to differentiate. What is dy by du? 2u. Okay, but what is my u here? U is cos x. And what is du by dx? It's minus sin x. That's it. 2u. Again, I have to convert everything into cos form, right? That is x form. So 2u is cos x. So 2 cos x and minus sin. Same thing, but no need to use this much and spend a lot of time here. You can directly do work on the power, then work on the base. That's the rule. I worked on the power, got 2 cos x. I worked on the base, I got this, and they have to get multiplied. This is how chain rule work for every composition function. This shortcut we can always do. Right? Now, finally, what is our f dash of x? It's minus 4 sine 2x. Got it? Right. So f dash of x is done. Let's get into the next part. Hence or otherwise find coordinates on f of x where f dash of x is 0. Okay. So here we have to find a point together in its coordinate form on the graph, but the condition is at that particular point f dash of x have to be 0, right? So first let's equate point like f dash of x equal to 0 and you solve for x. That's it. F dash of x, we just now find it. So we can use that minus 4 sine 2x is equal to 0. Sine 2x equals 0. Okay, no calculator allowed. So let me take this 2x as a. Sine a is 0 here, right? So when sine will be 0, that basic idea we have to. So this is just for an instance. We have assumed a is equal to 2x. Okay, and we will get back to that x form again. Okay, at which angle sine will become 0? So this is the sine graph. Quickly you can at 0, at pi, at 2 pi, like integer multiples of pi, right? So sine a will be 0, but we are solving for 0 to pi. So my a is 0, pi. Okay, also it's equal to 2 pi. Let's take for one complete solution. Now a is, I'm not looking for a, I'm looking for x. So 2x is equal to 0 pi 2 pi. So what is my x? X is 0 over 2, pi over 2, 2 pi over 2. So x is 0 pi by 2 pi. Okay. So if your values is enough, like from 0 to pi, you can accept more than that, we can reduce. So we got 3 values here, not just 2, right? Since we are solving for 0 to pi only, but here I'm not solving for x, I'm solving for 2x. So quite you can take the extended value, right? So 3 values for x we got. At these x values, f dash of x should be 0. But the thing is, they ask the coordinates clearly on f of x. So when x is, what is your y value? Y is f of x. On the graph we need, not f dash. So 0, pi by 2, and pi. Now a direct substitution. What is it f of x actually? The simplified version, 4 cos square x minus 3. Let's start substituting. 4 cos square 0 minus 3. Cos 0 is 1. So 4 times 1 minus 3, which is 1. Then here, 4 times cos square pi by 2 minus 3. Cos pi by 2, it's 0 actually. Odd multiples of pi by 2, cos will be 0. So first term fully get vanished and we got a minus 3 here. Then 4 times cos square pi minus 3. Okay, so cos 0 is 1. You can just visualize the graph. This is how it will be. 1, pi by 2, 0. Pi, it will be negative 1. So 0, it maximum, pi, its minimum. The next multiple of pi, its maximum. The next multiple of pi, its minimum. So in that way, so first pi is minimum, which is minus 1. So we got 4 times minus 1. Anyways, we are going to square it, right? So 3 equals 4 minus 3, it's again 1. So the coordinates, required coordinates are, we can list it out. And this will fetch you the complete score. 0, 1, pi by 2 minus 3, and pi 1. That's simple. And let's get into the last part. Sketch y is equal to f of x, and we have to clearly show the coordinates of any point where f dash of x is 0 and any points where the graph meet the coordinate axis. Okay, so these two conditions. Okay, and points where graph meets x-axis. This we already solved in one particular problem when f dash of x is 0. So this is the problem, right? When f dash of x is 0, what are the points on graph? So these points should be included in the graph. This already did, right? And next is points where graph meets x-axis. Graph meets x-axis means what is my graph? F of x. If it meets x-axis, f of x is 0. So also we have solved this. F of x is equal to 0 also we have solved, which is the first part. Let me show you. This is the x-intercept. So pi by 6 and 5 pi by 6 should be clearly plotted in your graph. That's it. These already solved. So major part is done here. Let's go to the graphic. Okay. And what is my f of x again? It's 4 cos square x minus 3. Let me draw the graph from 0 to pi. Let me take the page here. And when you see these points, right, it can be gone to okay, f dash of x when you solve, and that's basically give you maximum minimum. So we can analyze here, maximum is 1 and minimum is minus 3. So while you're graphing it, make sure in your x-axis, we can take 0 to pi, that's we are sure, 0 to pi. Okay, we have to break down it anyways. And y-axis still negative 3 I want, and in maximum is positive 1, right? So I can shift this little. Right. Also, what are the points, key points? You can mark it here. Sorry. Key points. The x-intercepts x-intercept are like pi by 6 and 5 pi by 6. X-intercept means y is 0, 5 pi by 6, comma 0. And the other key points are, we found 0, comma 1, pi by 2 goes for minus 3, and pi goes to 1 again. These are the key points. So I need pi by 6. Pi by 6 is 30 degrees. So let me divide 0 to pi by 6 form. So this pi by 6. Next is pi by 3. Next is pi by 2. Then you add pi by 6, you will get it. Or easily, if you want to do pi by 6, 30. So 30, 60, 90, 120. And then you can convert to coordinates. Anyways, we can do. Okay, let me show you in that way. That will be easy to understand. 120, then 150, then 180. Right? So 120 means it's multiply pi divided by 180. Right? So it's 120 pi by 180, 0, 0 cancelled. 2 pi by 3. Right? And then 150. 150 can be written as 5 pi by 6. Then 5 pi by 6 plus pi by 6 if you do, it's just pi. So it should be in radian, then only we'll get the full A1 as a mark, as a score. Right, and y coordinate is still 1. Maximum we need 1. So let's stop there. And minimum we need till minus 3. Okay, so this is minus 1, minus 2. Let this be minus 3. To the edge I have taken anyways. And next part, graphing. Let's plot the point. pi by 6 comma 0. So this is crossing point. 5 pi by 6 comma 0. The graph will cross. And this is marked, 0 comma 1 at x it's 0. And then at pi by 2 it's minus 3. So direct here. Then at pi it's 1 again. And we know how the cos graph structures behave. So this will go and it will cross here and it should go down, right? Because this is the minimum. Then it should rise. This is not a correct way, but yeah. So there should be a smooth curve and it should go like this. That's it. This is a sketch and we have clearly shown the coordinates. And even if you mark these, that will be also good. This is 0 comma 1, this is pi comma 1. This is pi by 6, you can highlight. This 5 pi by 6. And this is pi by 2 comma minus 3. So every points what they have asked is clearly shown. And this is the graph of f of x 4 cos square minus x minus 3. That's simple. So this carries 15 marks. I hope this video might help you. So thank you so much for listening. Let's meet in the next video.